Hello everybody, my name is Jake Mountcastle. Today is the 1st of April 2017, and this project is from my MEC 113 class, Materials and Processes of Industry. And I chose Kevlar as my topic. So Stephanie Kolick was a famous chemist that worked for DuPont as a researcher. In 1965, she was part of a team trying to create a stronger synthetic fiber. According to DuPont, the scientists were struggling. Then, Kolick broke the deadlock, DuPont says, by devising a liquid crystal solution that could be cold spun. Kolick took a chance and spun the solution into fibers more strong and stiff than had ever been created. This developed into what we know as Kevlar today, and this is Miss Kolick. So Kevlar is a long chain molecule known as a polymer, which consists of repeating units called monomers. A Kevlar fiber is an array of molecules oriented parallel to each other, which describes the crystalline structure. Kevlar is a polyaromatic amide. That is, it contains aromatic and amide groups. Other polymers with a high breaking strength often contain one or both of these molecular groups. So aromatic compounds are substances that consist of one or more rings that contain alternating single and double bonds in its chemical structure. So this is the element benzene, and here are double carbon bonds and then single carbon bonds. Amides are inorganic compounds derived from ammonia by replacement of an atom of hydrogen with another element such as metal. So here is the chemical formula of the monomer of Kevlar. As you see, there's double bonds and the single bonds. And here it is the polymer. There's multiple monomers. So the manufacturing of Kevlar. Kevlar's chemical structure naturally makes it form in tiny straight rods that pack closely together. These rods form extra bonds between one another, known as hydrogen bonds, giving extra strength. So the first step is that the rod-like Kevlar molecules start off in dilute solution. Second step, increasing in concentration increases the number of molecules, but doesn't make them align, as shown here. So at this stage, the molecules are still tangled up and not extended in straight parallel chains. And in step 3, the basic aramid is turned into fibers by a process called wet spinning, which involves forcing a hot, concentrated, and very viscous solution of polypropylene terephthalamide through a spinneret, a metal former a bit like a strainer, to make long, thin, strong, and rigid fibers that are wound onto drums. The fibers are then cut to length and woven into a tough material to make the super strong, rigid, finished material we know as Kevlar. And here's Kevlar right here. So the use of Kevlar. The most commonly known use of Kevlar is in bulletproof vests. Kevlar is strong, flexible, and light, so it's ideal for protective clothing and body armor. The tightly woven fibers of highly oriented polymer molecules are extremely hard to move apart, so it takes energy to separate them. A bullet has its energy stolen from it as it tries to fight its way through. If it does manage to penetrate the material, though, it is considerably slowed down and does far less damage. So other uses of Kevlar. Kevlar is used in many applications such as sports equipment, cables, building construction, expansion joints and hoses, smartphones, marine current turbines, and wind turbines. There's also many other applications you could be used in. Here are my works cited. Alright, thank you for watching, and I hope you have a great day.